earthworks on the core valley lines. I'm sure it's going to be very interesting stuff. Thank you very much.
Good evening, everybody. Yeah, I'm here to give a talk on earthworks on core valley lines. My name is James Dyke. I'm one of the asset engineers in TFW's asset management team. I'm a chartered geologist and a UK registered ground engineering professional, the ICE. My background is mainly in highway geotechnics. That's what I used to do most days, to work as a designer at Atkins before joining TFW. So I still feel like I'm relatively new to the rail industry, but it's certainly a learning curve and an interesting one. So what I thought I'd talk about was really what makes managing earthworks on the core valley lines a particular challenge. Not really going to go too much into detail about how we're doing that exactly, but just wanted to sort of throw a few examples together and show you what we have to deal with. So these are obviously the core valley lines. They've been in Welsh Government ownership since March 2020. Roughly 200 kilometres of track, 56 stations, spread over 7 routes, 6 passenger and 1 freight. The main freight line there obviously shown from Austrian Mannock up to Bargoed Colliery. So obviously managing earthworks is mainly about maintaining their stability fundamentally. And the sort of 3 main threats, I suppose, is what I was aiming at here to that stability. Could be sort of summarised like this. 2 of those are obviously water. You could argue 3 of them are. Perhaps the main sort of external threat to the railway from third parties is mainly around sort of drainage inflow and sort of management or otherwise of incoming drainage. But on top of that, obviously there's climate change. Not going to go too much into detail about that, but I suppose the concern with climate change is that more extreme weather is going to result in more rainfall fundamentally. So there's that, but there is also recently has emerged a sort of body of research funded by Network Rail and other asset owners and so on, that says that increased seasonal fluctuations of temperature, which will drive greater fluctuation in groundwater pressures, that greater fluctuation seasonally in groundwater pressure will actually act to cause the materials themselves to deteriorate and weaken over time. So climate change acts to amplify the forces that drive instability, but also to diminish the forces that resist it. The soil strength, essentially. So obviously it rains a lot in the upland areas of Wales. TFW's 1,500 odd earthwork assets are all going to be exposed to waters trying to get from the upland areas to the rivers, and they've got to cross the railway to get there. So, we don't necessarily have a huge range of geotechnical problems, not like you might see in other bigger regions, but the extent of our asset is affected by water, and is vulnerable to the instability it drives is quite wide. The types of failure that sort of broadly looking at here, I mean, the ones I've circled are the ones that are perhaps more predominant. That being as a function of the geology and of the environment, the valley's environment, mainly sort of groundwater driven, surface-driven translational flow, and then you've obviously got water flowing over the surface of the ground, acting to erode the slope basically, and you get sort of debris flow forming as a result. There's sort of a spectrum between these different failure modes to some degree, but obviously groundwater and surface water are the main drivers. As you move further down towards the bottom there, the speed of failure increases to the point where you get down to sort of rockfall where happens instantaneously. The time therefore that you've got to intervene before you've perhaps got any indicators that something's wrong, obviously is much less. And the further towards the bottom you go, the bigger the challenge. And these are fairly rapid, these forms of failure. So obviously there's the main threat is water, but understanding where that threat exists is one half of the problem. The other half is understanding which of your assets are most vulnerable, really. So in turn, when we think about vulnerability, we're interested really in what's the stability of the earthwork. In sort of design terms, we assess stability using soil mechanics theory to determine a factor of safety, and obviously that requires an awful lot of very expensive data, which it is obviously not something that's within reach. So that's really the challenge. So the big sort of difficulty really in understanding what's below surface, therefore in order to understand how your earthworks are going to behave, is one that's sort of compounded by the sort of variability that exists within the earthworks. Modern earthworks to modern standards, you can make some reasonable assumptions about how they've been built with a few bits of information, but Victorian earthworks, typically formed in sort of manners such as this, where scientific embankments was fairly common practice, is makes things a bit more difficult when you've got an embankment that perhaps a bit more like one right than the one on the left. So network rails sort of method for just assessing or characterizing earthwork vulnerability is this. The method is to give it a basic rating to the earthwork hazard index or earthwork hazard category. And it's a sort of condition-based measure of vulnerability that's inevitably going to be subjective. It's all based on examination data. Doesn't say anything about factor of safety, but it's what you can reliably sort of gather from observation, what you see at the surface, and then backed against the criticality measure that's in place, which is still very up to the risk matrix there. So earthwork hazard category is it's sort of determined or calculated based on an asset's characteristics, its attributes. That might be fixed attributes, the geology, the slope angle, the height, fundamentally the two most sort of important sort of determiners of how stable your earthwork is fundamentally. But obviously then there are other condition-based factors that come into it. The ones that are sort of most indicative, I suppose, of something being fairly problematic. Movement indicators, obviously you've got drainage there. It's there for a reason largely, to control either pore pressures or to assess surface waters. An indicator that there's a threat there. So each of these attributes then will score according to how sort of important they are as indicators of failure, as precursor indicators of failure. And there's a sort of statistics behind this in the how important these are statistically in the failure record. From them, data will determine the weighting that each parameter is given, and then the earthwork scored accordingly, and it puts you somewhere on the scale A to E from best to worst condition. So fundamentals are kind of geometry and geology. So understanding the geology is the first step. Almost all of our assets exist from the South Wales coalfield, which basically a syncline structure formed when I think what's now Africa colliding with the bottom out of Europe and form this sort of bowl-shaped structure within which you've got the coal measures in the middle, limestone around the outside, and then the underlying sort of old red sandstone outside the land. So, most of our assets within the coal measures, and they have particular sort of characteristics when it comes to materials and how they behave, so on. So looking at how our assets break down in terms of the, where they are on the hazard index scale. Network Rail sort of designed this system so that it was a sort of inverted pyramid distribution where it allows you to focus all of your attention or but more of your attention on the assets that are in worse condition at the top of the bottom of the inverted pyramid. And you would normally expect to see the lower, most of your assets in the lower condition bands. The fact that most of ours are, or a large proportion are in C, isn't so much an indicator of the condition being particularly bad, more so than maybe it is in other areas. It's more a reflection of the sort of fundamental things that control stability, like slope angle, gradient, that type of thing. It's just an indicator of the sort of vulnerability widely of the asset for the earth. Drainage, drainage is vitally important. If you've got drainage in place on your earthwork, then it's generally an indicator that there's a vulnerability there. All of these sort of drainage features here are going to be pretty critical, really, for controlling stability and limiting the risk of this type of failure happening. Got crest drainage, which would partly be to control groundwater that intercepts surface water, counter water drains on the slope to limit core pressures. And obviously we've got under-track crossings here, which fairly critical to the integrity of your embankment there. And obviously if it's for sidelong ground, as exists mostly in the valleys, the upslope drainage at the toe level would be pretty important as well. I guess that's what's that seepage line there is then to be so just a few examples of the sorts of problems that we've had, perhaps before we took the asset on in this case, but since as well. This is the northern approach to the tunnel. We've got the north portal of the tunnel here. So quite a few cuttings, about 25 meters deep. Quite an irregular crest line actually, and this is fairly kind of flat here, but then you've got these sort of valley features on the side. There's a slip here in March of 2017. No crest drainage here. It's probably the first thing to sort of notice. Now, I guess just to provide a bit of geological context, this is a section through Catholic tunnel, geological section comes through the Devonian sandstone, through the limestone of the carboniferous into the coal measures, and you're in the coal measures up the North Gordon here. So the cuttings have been cut through sandstones and mudstones. Mudstones quite prone to weathering their surface. And that's likely been a major factor in sort of being vulnerable to this type of failure. Also got some sands and gravels here coming in. Possibly could be a thin layer over the top of the underlying geology there. So what do we think caused it? Well, looking back at the records, obviously followed a period of high rainfall. It's likely there was a combination of groundwater and surface water dryness. We've got the wet and mudstones here overlying something more competent below, which could be sort of competent mudstones, sandstones, possibly. There's an indication that there's possibly some groundwater movement in this direction. It seems that this kind of looks like a combination of sort of debris flow and a translational slide, sort of stepped profile again, part of the slip, but then sort of more of a debris type, very sort of almost liquid type flow at the bottom here, which could be possibly what's gone on here, and maybe that's undermined slope. But there's an indication possibly there's some surface water overtopping from the upslope side here, and that's go back. The other thing to notice is these log piles here. Now, it may not be a bit of factor at all in this slip, but if there was a sort of uniform flow of water towards the crest line from neighbouring land, you might think that those sort of logs there might possibly act as funnel water towards the middle part of the slip. It could just be coincidence that the slip sort of coincides with that again. But it's just an indicator that other factors at or beyond the boundary that are often critical to these things happening. Another example of something that happened before we took the asset on was a landslip here at Rhondda. Probably, there'll be people on the call more familiar with this myself, but this is sort of obviously been important in us trying to understand the asset history, understand what sort of residual risks there are, and how we need to manage the asset in future. There was a slip on the downside cutting here. Again, it's like 30 odd, it's like 25 to 30 metre deep cutting, but quite steep. This core seems to have been water overtopping the crest from this car plug here because of a blockage in the drainage system. And that's washed out large parts of the upper bit of the slope, but also the lower part here. There's no crest drainage or any drainage to intercept any runoff from upslope. Not that it would normally need to be, but for incidents happening with externally causing that sort of water. The main sort of issue here really is the fact that the land boundary cuts across the middle part of the slope, which isn't sort of untypical of the sort of cross section you have to contend with. There's obviously been a history of something similar going on here with the star event so there. So there was some emergency work done by Network Rail, and I think you could see it in the previous picture actually, where to sort of to try and manage the risk within the boundary of instability outside. There was this catch fence installed. Obviously, the bottom bit of the slope failed, was rebuilt. But yeah, this catch fence was put in to try and sort of contain any further fail material from above. The other thing, when we picked this up after we took on the asset to try to assess the site and get a bit of an understanding of what residual risk there was after the emergency work, we could see that there were some overflows from these gullies in the car park right down to some chambers in the cess here. Sort of temporary measures really. So obviously something that if it is needed longer term, they sort of formalising in some way. So yeah, this clearly is still a difficulty in managing this site. As we looked more closely at the line chart, you can see that there's a sort of herringbone pattern on the kind of middle bit of the slope there, which when you look back at early 2001, I think this aerial image comes from, you can see that this is a system of counterflow drainage, which we didn't previously know about, and wasn't in the asset records. May well have dating from long before 2000, 2001. Certainly doesn't look particularly new there. So you know, but then obviously they were put in for a reason. And you can imagine that drainage was, well, certainly at the time, was considered fairly critical. One of the sort of concerns with that type of drainage is you know, it has a sort of very limited lifespan. This recent work done by the Transport Research Laboratory into how, you know, how long these things can be sort of considered functional without, you know, even with regular maintenance. And they found that, you know, really refurbishment replacement is necessary by the time you get to sort of 25 years. And you know, it's already been in that long, quite likely, with very little maintenance in that time, given that there was no record of it. So, yeah, you know, that's obviously a sort of concern about how we manage it going forward. One of the important things to consider with countable drainage in terms of design, and also with maintenance, is what's its sort of design function? Is it there to manage groundwater, or is it there to intercept surface water as well? You can imagine, given the sort of nature of the site and the fact that there's, you know, you're having to protect against instability driven from things happening outside the boundary, it might be there to intercept surface water, or more important, that it's kept free of vegetation, you know, cleared from all the sort of vegetation debris, so it doesn't get clogged at the surface. This is a slip that happened in May last year. This first of May, after a prolonged period of rainfall, first train out from the depot from Rumney past the slip. I don't think it hadn't blocked the track, but there were lots of trees down with it, and the train struck a tree on the way past, damaged the unit. But thankfully, it wasn't too severe. The debris was cleared away, and an emergency speed restriction was put on once this crest ditch here, which you can see was hand cleared, and some barriers put out, or rather, I think the speed restriction was put on after the debris was cleared, but it was lifted after that work was done, just to try and get the ditch flowing and to get some temporary restraints in place. So, having a look again at the top of the slope, again, this crest ditch here seems fairly well defined in places on the LiDAR, but in others, really not. It's really badly degraded and heavily overgrown. Lots of, you know, trees growing out of the ditch. Again, this wasn't in the asset records, so, you know, quite likely it really hasn't had.
Is it sort of ditch within the railway boundary?
It was, yeah. The boundary is sort of crossed just at the back of the ditch there. We can see there's an incoming water course there. This ditch is sort of, the intention is for it to intercept that flow, but you can see there's a sort of that sort of linear kind of feature extends beyond it. So there's been some overtopping there, and not just that, but there's been some quite heavy seepage below the ditch as well. So, you know, it might not just be a ditch overtopping, probably there's something else coming in as well. It seems to have caused it. So, obviously, with, you know, the importance of drainage, trying to improve the asset record of drainage, we tried to do a bit of work looking through all the records to try and identify stuff that maybe isn't formally registered as a drainage asset. Try and see if ultimately we can get it into the records. We've also looked at the LiDAR data. I mean, the images you saw before are quite useful for doing that, OS mapping, and just going through all of that data. There, you know, we think we've been able to identify these numbers of earthworks with suspected unregistered drainage, the dark blue ones being ones that we should do about drainage that we already know about. So, that's roughly sort of 40% of what we think is out there is unregistered, which sort of ties in very roughly with what Network Rail have sort of estimated before. So that's really the crest drainage and earthwork drainage, but sort of equally critical are sort of under track crossings that receive carriage flow, fluids like this along the railway and off into neighbouring land. Again, something that happened a good few years ago. One of these culverts became blocked. The track was flooded. Also flowed down the 4 foot down the embankment and then washed out this large sort of chunk of the embankment here. So a critical drainage asset. A similar instance really here of something that happened a couple of years ago on the Cardiff and Merthyr line, where sort of critical part of the network, following sort of, I think it was about 40 mil of rain in 24 hours, but that was on top of about 3 days of continuous rain. And it was this sort of large washout of the embankment shoulder here. It's probably the water's come underneath the track through this ashy layer and to cause the failure in the underlying sort of sandy, silty embankment film. The cause was this ditch here becoming blocked, and that overtopping the ditch, flooding the track, and water obviously made its way through. So again, sort of critical sort of drainage asset that have become blocked. Something that our maintainer, Amy Infrastructure Wales, is doing some good work on the moment, is looking to monitor some of these critical drainage assets, so that we've got some warning when debris builds up on screens to inlet chambers and culverts and so on, so we can go out and clear them before there's a flooding problem which can cause damage. So this equipment sort of gives you sort of 3 monitors the water level, but gives you 3 sort of triggers according to whatever level you want to set. Sort of red, amber, green type of alert. That's linked into control, and then switches on a CCTV camera. You can see what's going on, and the teams can be dispatched then to clear the screen before something occurs. Something else that we're looking to try and do is to sort of see if we can get even further, earlier warning of what's happening. So, once you understand the normal flow conditions within these sort of chambers, within these sort of inlets, is there a pattern, or can we relate that to the actual rainfall that we've seen, and then make predictions about what's normal, and then anything that's outside of that, you will have an alert to ahead of time before maybe it reaches a certain sort of threshold on the monitoring equipment, and look to try and improve our rainfall data by installing a series of weather stations at various places on the network. The blue ones are NRW rain gauges, but pink ones are some weather stations that we've installed these mainly at the heads of valleys where you expect to see the higher rainfall, a bit of locations as well. One other thing that we're hoping that would be useful for is to provide us some data that we can compare with the occurrence of landslides, so that if we understand the amount of rainfall that's accompanied a landslide, we can again understand the conditions in which landslide risk is increased, and then that becomes quite useful then for adverse weather planning and so on. Welsh Government are doing a sort of exercise with South Wales Trunk Road agent doing just that, see if they can come up with some threshold levels to inform their route stewards about increased landslide risk. And this is the opportunity perhaps for us to develop that in a way that might be useful to us. So there's surface water, groundwater, problem solved earthworks, and predominantly not really an earthwork problem. This part I thought it was quite interesting, one kind of illustrative of a problem that does exist in earthworks as well. So one of river erosion. So this was some bank erosion that happened below Quakers Yard Viaduct, which you may know is a six-span masonry arch viaduct dated from the 1840s. Storm Dennis resulted in some unprecedented high river levels, and that caused the bank here to overtop. You've got this sort of plastic sheeting here that was used to protect the bank, and it's washed out the corner of the bank here. The loss of that material has undermined the slope, which has caused a slip further back up the slope. So obviously here the concern is, does this pose a risk to the violent foundation? So looking into the records, first thing we were concerned about is the foundation on rock. Now all of these are, but this one has obviously been taken much deeper during the original construction of the 1840s viaduct here. This was before it was wide in the 1860s. But one thing you can see from here is that the river used to flow around the back of P&2, and there are these octagonal piers that are sort of designed in a way that relieves that flow around the back. But yeah, I think the concern really is with this foundation, in that this one isn't on rock, it's on hard gravel, albeit sort of close to bed level, it's still not quite on rock, it seems, according to a paper by Samuel Downing that was written soon after the original construction. So fast forward to the 1860s when the viaduct widened. You can see, I think it was 1860s, I think you can see that the river no longer flows around the back of the pier here after it's been widened. And it's now been filled with all this debris that appears to have just been spoil taken from the approach cutting, and the approach cutting was widened. So when you map that onto the original, when you map the 1840s ground surface onto the current ground surface, you can see that there's this large build-up of material on the slope, and it's largely that material that's been lost by the bank erosion here, with this sort of hatched area having been washed out and that then sliding down slope. So not something that was likely critical to sort of stability of the pier, but there's clearly an erosion problem that needs addressing, and it's something that we're in the process of addressing. I don't have any sort of further sort of information to give you on that. Just a little bit report. Another example, just again, river erosion problem, but in this case, not untypical with the railway on embankment right next to the river. This is the Babcombe Boy coking works on the Aberdare branch. it's obviously very steep at the embankment shoulder here, not much left of the cess. When you look at the bank, you can see it's quite prone to sort of slumping. It's a very sort of sandy, silty, alluvial material. So, it's very prone to erosion. It's a fairly kind of robust protection, I would have thought. And the other challenge of in river working in the valleys and engineering to provide protection against river erosion is the energy within the river systems is it's so high that often it limits the options you've got available, especially if you're looking to sort of more sustainable methods. Obviously, it's hard to avoid sort of steel and concrete really. Obviously, we've not just got embankments on riverbanks, we've got embankments set back from riverbanks in areas that are nevertheless prone to flooding. One of the other things we're looking at is to work with Cardiff University to create a predictive flood model, an early flood warning system, but also a model which will allow us to model some future climate change scenarios as well, to understand future risk, how much of our network is going to be exposed to flooding, to erosion problems, all of that hopefully be useful. So this is the sort of a bit more about the modelling work and how the model is developed. Cardiff University built has done an exercise or a pilot study for the building model by creating a sort of a version of a model that's collaborated around Storm Dennis, looking specifically at an area of the area that probably floods most heavily, local biolites, the Aberdare branch. And this is the model sort of sequence recreating Storm Dennis. Yeah, the idea is that that could be used to calibrate a model that could be developed and rolled out more widely. That's it.
Right, you. Okay, right, I'm sure. Is there any questions online?
Not yet.
Hmm?
Not yet.
Okay. Right, any questions in the room? Alex?
That's an easy one. If you look at my accent, it's not quite Welsh, it's Australian. I got all my fair share of floods, so happy to be Queensland. You mentioned before about obviously the risk of not knowing the assets which should be sort of collaborated, built, and then not knowing the assets that are known, and also the risk of climate change, etc. Which is you see the bigger risk, the ones of actually assets which are right there, doing a good job today, and then they will fail. The building of there, or the fact that climate change has become on and actually should change all the modeling and for the campus regions. So these things that work, the less than 2 people, then all the better.
It's a bit of a cop-out answer, isn't it, really? But they're both challenges, aren't they? And just in different ways, I guess. But I suppose that climate change just magnifies everything else. So it magnifies the challenges you get in managing water generally. I mean, it's the uncertainty of how quickly climate change will take effect. I mean, it really is, isn't it, to some degree? But I think that the drainage problem is something that it's clearly a problem now, even under the current conditions, isn't it? And it's not just finding that drainage; it's sort of renewing it, it's bringing it into some use that will only become more important as time goes on. So yeah, it's both, isn't it? Really, I'm thinking.
Thanks.
So, any other questions? Oh,
we've just come to the end of an unusually dry spell for the winter. The last 2 months have seen very, very little rainfall, and river levels going up the valleys are very low. I guess walking over here this afternoon, there were a few spots of rain, and more rain is forecast for at least the next week.
it's a warning, a yellow warning for tomorrow and the day after.
Could a increase in rainfall particularly affect things after a dry spell?
Yeah, I think infiltration is lessened, isn't it, when the ground surface is hardened? So the potential for runoff is greater. Water getting towards the railway faster, towards the river systems faster. So your railway is obviously exposed to that from the upslope side, but also from the downslope side with proximity to the river. So all of those examples really are sort of indicators of something that's more likely in those conditions.
Okay. Any other questions?
Really preventing something or dealing with something when it's happened. If it ain't broke, don't fix it. But commonly with drainage assets, we don't know they're there in the first place, particularly crest drains, which following the 1960s decision consequent upon steam disappearing that we wouldn't mow the embankments anymore. We forgot about them completely, and so that they're all full of trees and stuff, whatever else. So it would cost an absolute fortune to clear them out to do it. But what amount of budget cut do you think is appropriate between preventing mishaps, as with crest drains, and by opening them out and by dealing with the consequences of other failures and track washouts? Is it considered in today's budgeting?
That's a difficult question, isn't it? I think you always want to, you're always going to want to put your money into prevention, aren't you? But obviously, you need to be able to focus that prevention in a way that provides you the efficiency, because otherwise, then it's no more efficient than responding to the consequences. The challenge you've got when with climate change in particular is if things are happening, things are deteriorating so quickly that you're spending more money on repair and dealing with the consequences than you want to, and that leaves less prevention. Then that's not a great place to be, is it? Because you're recovering from that under sort of budget constraints is going to be almost impossible. So I don't, in terms of how much is required to sort of prevent you from reaching that sort of tipping point. I think that's the area that we need to do a lot of work still. I think there's things we can do to prioritise where we look for drainage and look to bring it back into use and so on. But I think how we sort of tie that into deterioration models for earthworks in a way that allows us to sort of understand that balance that you're talking about. That's a difficult one, but something we need to keep in mind and try.
It's a major challenge for Network Rails as well, in that when you start quantifying the amount of earthworks which are not in great condition and are what we've talked about tonight, heavy rainfall events or prolonged rainfall events, it is a major challenge, which I think people are still focusing on. But certainly in the CP7 budget for Network drainage and earthworks got a big chunk of the budget, recognising that it is probably now flooding is our biggest, and I guess the same in the valleys, it's the biggest disruptor of train surfaces. So now,
and when you do anything, and when you do anything particularly crescent drains, you've got to do it right, otherwise there's
Yeah,
a
we-
HST in the river.
Yeah, so I can certainly think of quite a few places where there was a crest drain and it was in good condition, but the Storm Dennis scenario just completely overwhelmed it. So. Right, I've got a question. So, where we've got places, and there are quite a lot in the valleys where third parties are up the top of the slope or up the hill or beyond even. And I would include the Highways Authority as part of that. How receptive are these people being to, when you knock on the door and say, look, we've got you're chucking this water down here, do you realise what's happening?
I think they are receptive. I think we do need to do more to improve communication with local authorities. I think that the big challenge you've got with that is that sometimes they know even less about what drainage they've got than we do about ours. So that's part of the problem. I mean, there are obviously, highway gully outfalling directly to the tops of cuttings all over the valleys.
Yeah.
But we inspect those as far as we know, ones we know about anyway. But yeah, there will no doubt be ones that we're probably missing. And if we had adequate records, then we could that would certainly help. But yeah, it seems to be a bit of a common problem that everybody has, really. Lack of drainage asset knowledge.
Yeah, well, ultimately it comes down to the fact you don't do anything about it, it just runs downhill, doesn't it? So, yeah, once it's gone off your land, they're not bothered anymore. So, yeah. Okay, yeah. So, has that changed with the Transport for Wales now being part of the Welsh government involved in planning and that, or is it too early for that?
To be honest, I don't know. It's all I know, really, because I've not sort of worked for Network Rail. I've not seen what it was like with them, so it's hard to compare, really. But yeah, it's hard to say.
Okay.
Another question. With the city, you've got lots of data coming from whether it's rail or Trans Wales or consumer networks, etc. And that I think what we can see was a huge sort of population of assets. It's a place for AI. That's something where when you use it to actually swamp the data. So fill that out a bit.
Yeah, that's an interesting one. I think I think it's the data really is the thing that's difficult to come by with Earthworks. It's in the most of the data we've got is from examination, and it's always going to be somewhat subjective, even though the Network Rail methodology does a good job of sort of keeping that subjectivity, or at least managing it to a level that gives you kind of a reasonably objective, consistent method that's based on some underlying data, some statistics about failures and so on. It's trying to get data that has a bit more of a basis in the fundamentals of what keeps a slope stable or drives its instability. That's the challenge, I think. And once you've got a lot of data that you can rely on, then AI opens up possibilities to be able to use it. But yeah, I think that's kind of the area for Earthworks. I think that everybody's looking at modern technology, new technology. How's it going to provide the data we need to help us understand these assets better? That's what sort of techniques, monitoring, remote sensing, things like that.
Okay.
Yeah, that's one. So, listening to what you're saying, I remember the pyramids and some of the other work as a classification, a lot of it was C, level C. Are there potentially like D levels that you've got your eye on at the moment, that maybe the next one to go? You know, is there a list in terms of, I know there's Comply Pro and there's a risk register, and that's always available.
Yeah,
There's
a D and E, isn't there? The sort of top end of, I suppose what would have been termed in the previous kind of terminology, poor condition.
Yeah.
I think a lot of these seem to be rock cuttings, don't they, because of the risk of.
I think with you wouldn't really want too many E rock cuttings, because for that reason. So I don't think we've got any, but there's a lot of Ds. There's a lot of Ds across different asset types, embankments, soil cuttings, rock cuttings. It's a very large number to focus your attention on. You're still looking at a huge net. So how do you go further into that, and how do you put them in some sort of order? And that's where it does become quite labour intensive. You have to. There are sort of ways in which you can sort of look in more detail, but it relies on a lot of data, which, as I said, is quite expensive to come by, honestly, isn't it? So that's the difficulty.
James.
You mentioned some innovations in terms of LiDAR and remote condition monitoring and AI potentially. Are there any kind of innovations in actual in the Earthworks world in terms of actual, I don't know, repair techniques, or because I'm not aware of any, so I don't know, but maybe there are.
Yeah, to be honest, that's not an area I've seemed to have spent the last sort of 4 years looking. Sorry, that closely. Most of it's been on sort of trying to sort of understand the asset. Trying to prioritize and things like that. But I mean, I don't know if the sort of earthworks industry is looking at any sort of innovations, right? Sort of, or Chris may know.
There's been a lot of options. From the wider, so I'm Chris Sedder, the AV consultant. So first of all, there's a Syria guide that's about to kick off, which is Earthworks drainage. So they're going to look at it across all the types of different assets. How you talk about so that's a pretty area where we need to get things right. It's not where balances, maps, frankly. The other area I think is in nature-based solutions. So providing vegetation that will establish itself. It can give you on the edge, but there's not a lot in that. But something that establishes itself that doesn't need stacks maintenance. There is going to produce trees that will cut down later on, and that's all in grabs. And there's other elements such as moisture monitoring, so that you've got James and I like things to be dry, but trees don't like things to be dry, and vegetation doesn't like things to be dry. So there's a lot of it. I think that's the space where like innovation and trying to get this in a position where they make themselves stand up like a sand dune.
There's one that we're going on actually in TFL, a very common actually, but a TFL slide up there. An issue with drainage. We're looking at a sustainable vegetative retaining wall system in a very environment.
Right, to rebuild the slope below a fake crest drainage.
Create the wall, which will then be keyed in to the bench and perhaps and geotextile underneath it as well. And it'll just basically sort of, you can align the drainage the way you want it to go, and then rebuild the potential area which is really poor and failed. Create a nice solution which is quite cost effective and quite easy to install, because you can install it either from top above literally by hand, or trackside, you've got a bit more money, a bit more time to do it, with just a sort of small minimal amount of workforce. And you can, we have our own design systems in place where it gets the sliding and checking to make sure it's heated properly so it doesn't in fact create a problem in itself. So it improves the drainage as well, and it will look good from the train's point of view as they're passing it, so they won't actually notice that it's even there once it's built. So it just look like the slope wall vegetation.
Yeah.
So yeah, Chris is right.
Sounds
It just got quite a lot of detail actually.
Do you think we've actually reached the point where we're going to actually need to replace some of these earthworks?
I think it's you just looking at strengthening of our new really, or you know, making sure they're adequately drained really. That's sort of I know there are obviously lots of constraints that you've got to work in order to do that.
Yeah.
But I think that's still the most realistic and kind of practical approach. Yeah, there's always a method of strengthening.
Yeah, I mean, we've also rebuilt a few earthworks recently, and it's colossally expensive to do. I mean, at least you end up with a solution which is obviously pretty good, but you only touching a tiny little bit of the network there.
So access in some areas, valleys as well is sort of difficult, mostly, isn't it?
Yeah.
So yeah.
Right. Any more questions? I've got one as well. Is there any particular, we had a talk from one of your colleagues about weather stations some while ago, and they were just looking to set them up. So I'm just glad to hear that sort of moving now. Are you finding that the rainfall is still as predicted, or are we getting more and more really extreme events now? It's storm events, so.
Yeah, probably answer. Yeah, it is quite excessive, and the chart that Jake showed earlier on showed the annual rainfall values from the Met Office doesn't reflect what we're getting with rain. So last year, Trevor West area,
We used to talk
and
about it.
I think last year we got 3.2 meters of rain in Trevor. The next nearest end was Aberdare, that was about 2.5 meters. So both those values are, well, the Aberdare is already at the top end of the Met Office prediction for South Wales, and the Trevor value is about 30% above that again. You compare that to Rugby, which is only 12 kilometres to the east, and that was down in less than 2 meters. So you've got over a meter difference in rainfall in a 12-kilometre area.
Yeah, so we're already seeing unprecedented amounts of rainfall in those areas.
And I think from the storms at the beginning of this year, we were reaching levels of 104 millimetres in a 24-hour period. Some locations, which is actually 250% more than the RCP 8.5 value relative to the 2040. So we're already way above the climate predictions nationally.
That's worrying in itself.
I'll take it down to tell the rest of the table. It's astonishing. But that's just going to be,
Yeah, nothing actually. But yeah, we had quite a few periods where we had really extreme 24-hour values.
Yeah.
You know, way above 60, 70 mil. And then the actual instantaneous rainfall values in some places, the hourly rate was 315 millimeters an hour over a 2 or 3 minute period. So very, very intense rainfall values. So you can imagine why you get, you know, severe problems with surface runoff.
yeah.
Well, yeah, I mean, particularly as the valleys is quite, I mean, it's getting more and more built up as well, isn't it? Yeah, so. Okay, got any questions online?
No.
Okay, right, any more questions in the room? Okay, Well, I'd like to call upon Lee to propose a vote of thanks.
It's been very interesting. Thank you, James. I was thinking about when I was working for BRP residually for a number of years, and we had responsibility for a closed branch line up one of the valleys. It was Halls Road and Pennar branch, which started in the Ebro Valley, then crossed over to the west and went up the Sahrawi Valley. And although it was a closed branch like disused land, we had endless problems with drainage on it because of blocked culverts, collapsed culverts, buried pipes, unknown pipes, and we wouldn't know anything about them until somebody's complaining because somebody owning neighbouring property has got flooding in their back garden or is coming down towards their house or their farm or whatever. So we go poking around and we find, oh, there's a culvert here or a pipe or whatever, which we just didn't know about, so we had to dig it all out. So but it's incredible how one blocked pipe could cause so much damage. So it's interesting to know that they've got people like yourselves on board now in TFW looking at that, because I think in the past I don't think we had ever had anybody, certainly not at a local level, dedicated to looking at purely drainage and earthworks on the local railways here in the South Wales. So thank you for that. And as Andy said, the future does look very scary with these increased rainfalls that are being forecast. So I'd like everyone to join me in thanking James in the usual way.
Right, just before I close the meeting, so our next, the 12th May meeting is it's the rescheduled one for March, when Craig Fisher, Network Rail's of Network Rail, is coming to talk about operational performance. So I'm sure that will be of interest, and to hear what he thinks of us engineers. Okay. So, and has everyone signed the list? Everyone signed in? Yeah. Is there any issues arising from the notes of the last meeting? If there is, I'll be surprised. But, yeah, no? Right, we'll take them as a true record of the meeting. So some of us will be adjourning to the Prince of Wales after this. If you want to come along, you're more than welcome. Okay. So I declare the meeting closed. Thank you very much.